Welcome to the How to Program with Java podcast, where all you need is the desire to learn, and you too can become a Java programmer with absolutely no knowledge of programming. And now, your host, Trevor Page.
Okay, thanks everyone, and welcome back to the How to Program with Java podcast. This is episode number 4. We're sailing along here, and today's topic will be about data structures. So let's start right off with a nice definition, like I tend to do from Wiki, so we can look at what a data structure really is. So in computer science, a data structure is a particular way of storing and organizing data in a computer so that it can be used efficiently. Okay, and that's the key here is efficiency. Okay, so how can we use data structures to our advantage when we program? Okay, and this is a global topic. Data structures exist in pretty much any computer programming language that you can imagine, and like I said, they're all about efficiency. So what do I mean by that? What do I mean by efficiency? Well, data structures help us to minimize the amount of variables that we create. Okay, we've talked about variables before and what they're used for in programming. So data structures just allow us to reduce the amount of variables that we actually use in our programming code. So let me elaborate a little bit on what a data structure really is in Java. So in Java, there's 3 different kinds of data structures: a list, a map, and a set. Okay, these things are known as collections in general. That's the generic term that we use to define these data structures. Again, they're collections. It's a list, a map, and a set. Those are 3 very commonly used data structures in Java. So let me start with a list, and then I can use that to explain to you how a list or a map or a set can be used to reduce the number of variables that we have in our code. All right, so let me start with a list. A list is used to really store a bunch of items for later use or for later iteration. So a list is exactly what you would think a list should be. A list, for example, is like I've talked about a list of contacts before. You have a bunch of contacts, perhaps in an address book, like a physical address book, where you list the contact information for your sister and your brother, your girlfriend, your boyfriend, your father, your mother, whatever, right? You can actually put all of that information into a list data structure in Java, and it will allow you to do certain things with each of those contacts. It allows you to get the contact. It allows you to add new contacts. It allows you to remove contacts. Everything that you think that you should be able to do with a list of something. Okay, just like you had a list in writing in front of you. You can scratch things off of your list. You can add things onto your list, and you can look through the list to get items or something that's listed in the list. You can get it out and I guess consume that particular item in the list. Okay, so then fair enough, you get the idea of what a list is, but how does this list reduce the number of variables that you can actually have in your code? It's fairly straightforward. So let's say we have a list of 10 contacts. Okay, 10 different contact information that you have stored in a list. Well, if you do it in a list, it's really one line of code to create your list. Okay, when you create this variable, it's still a variable that you do create, but you create it and then you can add an item to that list via another, specific piece of syntax that I don't want to get into here. I'll leave that for your homework later on. So if you were to create this list and populate it, you would be able to have this variable that stores in it your 10 contacts, okay? But if you were to not use a list, you would have to actually create 10 different variables with that information inside of those 10 variables. All right, so 1 variable versus 10. Okay, so that's, helpful, but this is where the power of lists, or more generically collections, because collections is a generic term that we use to refer to these data structures, which are list, map, and set. The real power of the list, or collections in general, comes from the fact that they're dynamic. Okay, so when I say that they're dynamic, I mean that they can change during the flow or during the running of your program. So if you had a list of 10 contacts, you could at any given moment, let's say the user, you have some sort of an interface that allows the user to click on a contact, and then they could choose to delete it or edit it, or maybe add another one, all through different clicks of different buttons, okay? So they could click remove, and we could just remove that item or that contact from the list, right when they want to have that happen. Whereas if you had, let's say, 10 variables written down in your code, that's what I would refer to as more static. That's more, that's not very dynamic. You have 10 variables, you've written it yourself in code, it's called hard coding. If the user were to click on remove, you already have 10 variables declared, so that's not really helpful. You're now essentially wasting an entire variable, right? Because you've declared 10 variables, you have to remove one. And now what does that really mean? Well, it means you're just not going to be using one of the variables, and that's just a waste of memory, right? But let's say, even worse, they want to add an 11th contact. Well, now you're in a real bind because you've only created 10 variables. So now you're going to have to stop the program, you're going to have to go back into the code, you're going to have to physically type in, okay, I want to add an 11th contact variable and initialize it and get it all ready for the user to be able to add this 11th contact. And that just makes absolutely no sense whatsoever. That just completely ruins the entire concept of what a computer program should do, okay? It's just ridiculous. So that's why these things called data structures exist. They allow us to, or they give us the ability to have a program that will be able to operate dynamically and change its behavior based on user interaction. So that's kind of the complicated way of saying that data structures are useful, okay? So just take my word for it. So to jump back to the list, it's a data structure that allows you to, as I said, add something to the list, remove something from the list, get something from the list so that you can do something with that object or that item that's in the list. But another concept that goes along with a list is something called iteration. Okay, so if you have a list of 10 contacts, you could actually iterate or step over or flip through, however you want to think of it. But the actual programming term is called iterate over. You can iterate through the list and go through each item inside of the list one by one by one by one until you reach the end of the list. So this is usually helpful if you're using contacts. Let's say you wanted to send an email to everybody in your contact list. You could just iterate through each contact and add that to your to field in an email. Like if you're constructing an email, you say, this is the to. I want to send it to this person, to that person, and that person. You could iterate through your list and just kind of populate that to field in the email with every single person's email address. All right? Fairly straightforward, fairly simple. So let's move on to another data structure in Java. Like I said, there's list, there's map, there's set. Those are the three most common ones. Let's talk about the set, all right? And I'm talking about the set now and not the map, because the set is very much closely related to a list. You can think of a set as a list, except for one important difference, okay? This data structure, the set, removes duplicates, essentially. So it's essentially a list. You can do everything with a set that you can do with a list, except for the fact that it does not allow you to have any duplicates in the collection, in the data structure. So this is really useful when you want to do something like, you want to remove duplicates. So let's say you want to have store a list of words that appear in a sentence, but you only want the words, you don't want to see any duplicates, right? So you would write out a sentence, or you would read a sentence like from a file, or maybe you have someone type in an actual sentence on the screen, and then you want to look at every single word that appears in that sentence, and you want to store that, or you want to display that in some way, shape, or form. Let's say the sentence uses words like the or something like that over and over and over again. You don't care about keeping track of how many times the word the or the word or appears in a sentence. You just want to know that it did appear at least once. This would be a good example of when you would want to use a set, is when you would have a requirement like that. Okay? Generally, in the real world, you're more concerned about, removing duplicates from some sort of database table or something like that, which is kind of outside of the scope of what I want to talk about right now. So that's why I thought of an example with keeping track of what words are in a sentence, because that's more relatable at this point. Not really something that you'd ever probably create in a program, but just for an example, so you can kind of get your head around what a set is and when you'd want to use one. All right, so a set is pretty much a list, only it gets rid of, or at least it doesn't even allow you to store a duplicate. So let's say that you have a set, you've declared a variable and said that the variable's type is going to be a set, and you try to add the word the, okay? But basically what the set is going to do is it's going to say, okay, do I already have the word the inside of me? And if the answer is no, then it says, okay, go ahead and add this word to my list, to the set. There you go, it's in there now. So then later down the road, you say, okay, add the same word, the. You try to add it to the set. And this time it's going to look and say, okay, nope, it already exists inside of the set, so I'm just going to ignore the fact that you want to add this word. All right, that's basically what it does. It just ignores you. So there's no big failure, there's no strange behavior. It just says, nope, don't worry about it. So that's very powerful. That's very useful. So that's a set for you. Now, as I said, these are all data types, which in Java we call collections, which is the generic term. So there's one more frequently used collection or data type, and it's the map. Okay? So the map is a little bit more complex than a list or a set, but with complexity comes usefulness, right, and efficiency. So a map, the way I can describe a map is like this. It stores stuff in such a way that it's like a key and a value, okay, a key-value pair. So in other words, for a given something, or for a given object, what is the something else? What is related to this object? Okay, and that might not make much sense because that's kind of a generic way to describe a map. But a good example of this is when you would want to store something like a car's make and model. All right, so again, key value pairs. the key is usually something that is unique. All right, just like we talked about, a set only stores unique things. Well, for the map, it has a key and a value. The key is the unique part. So how this applies to cars with makes and models is there is a Honda Civic, there is a Honda Prelude, there is a Toyota Corolla, there's a Toyota Celica, there's a Toyota RAV4, okay? So you can see there's some repetitiveness going on there. Honda Civic, Honda Prelude, the Honda or the make of the car appears more than once. And let's say we'd want to be able to display, when asked, we want to display a list of the Honda cars. All right, so this would be a good example of when you'd want to use a map. All right, so you have Honda would be the key of the map, and the values inside of the map would be things like Civic and Prelude. Or inside of the map, we could have a Toyota as the make, as the key, and the values would be Corolla, Celica, RAV4. All right, Ford, Focus, Mustang, an Audi R8. All right, you see the kind of pattern that's going on here? The Honda is unique, but the Honda can essentially point to a Civic or a Prelude. So like I said before with my definition, for a given something, what is the something else? Well, in this case, it's for a given make, what is the model? Okay, for the given make, well, the make is Toyota. What is the model? Or what are the models? Well, Toyota, Corolla, Celica, RAV4. You get the idea? So this is kind of a nice, powerful way that you can store information or data into an actual data structure in such a way that you can use it in your programming. All right, so the perfect example is, well, I want you to output all of the types of Toyotas. Okay, so you've seen this before. I'm sure you've seen this before. Let's say you're filling out some sort of insurance, car insurance, for a quote because you want to get new car insurance quote. You'll go to a website, and the first thing it'll ask you is stuff about your name and your driver's license and that kind of thing. But then it will ask you, well, what kind of car do you drive? And you'll see a drop-down, okay, a little drop-down menu. And it'll say, what is the make of the car? You'll see the drop-down, and then you'll see what is the model of the car, and you'll see a drop-down. But when you look at the model, or maybe the model doesn't even appear on the screen if they want to do it that way. But usually the model, if you have a drop-down, you click on it, it's empty because you haven't yet selected the make of the car. Okay, so I guarantee you that if they want to be doing it a nice way, they'd be using a map, okay, this map data structure. Because as soon as you click on, okay, I have a Ford in your make, well, then it goes into this data structure, this map data structure, and it says, okay, Ford, now what types of Fords are there? And it's going to point to, so the key of the map is the Ford, and the values that the Ford points to are the Ford Focus, the Ford Mustang, that kind of thing. So then, on the front end, on the screen that you see in front of you, the user interface, the model will then say, okay, what are the valid selections? Well, Focus, Mustang. Those are the valid selections when you select Ford. Or let's say then you change the make to Toyota, and then boom, the model drop down then populates with, it gets rid of Ford Focus and Ford Mustang, and it replaces it with Toyota Corolla, Toyota RAV4, okay? So that is an exact, perfect example of when you would use a map. And these things, let me tell you, these requirements to use a map are all over the place, okay? A car's make and a car's model is just one of, like, hundreds and thousands and tens of thousands of examples when you could use a map to your advantage. And again, this all relates back to reducing the number of variables that you want to create. Because could you even imagine trying to create the car make and the car model variables in such a way that it could dynamically change with what the user chooses? Like it just becomes really complex and really annoying to try to figure out how to use this data in this sort of two-dimensional way or one-dimensional way, however you want to look at it. It's just really annoying. But when you have these data structures at your disposal, the list, the map, and the set, you can really more easily solve everyday problems. You can solve problems that you would be given in your job as a programmer. Okay? So, let me see. Let me go through my notes here and see if there's anything else I want to talk about. Yes. So, the collections that I've been talking about, the generic collections, one interesting thing that you can do with them is that you can store one type of collection or data structure inside of another type, which is really neat. So let's use the example of a map. Well, do you remember how I said we have a make and a model? The make is the Honda or the Toyota or the Ford. I'm sure you remember this. The model is the Civic or the Prelude, that kind of thing. Well, what would that actually look like? Well, when you think about it, the key is just a singular variable, essentially. It's just a string is the variable type that we would probably use, is just a Honda or a Toyota. But if you think about what it points to, what the value is for the map, it's really just a list. You know, Toyota, Corolla, Celica, RAV4. That's a list of models. Okay? So that's kind of cool. You can actually create a map that has, as part of its value, a whole nother collection, a list. That's cool. You could even use a set, because actually a set would probably make even more sense in this case. You'd have a map with a string and a set as the value, because you wouldn't really want any repeating values for your models. You wouldn't really want to have the choice of a Civic or a Civic. It wouldn't make sense to have two. So there you go. That's something that you can then put into your code as part of the requirements. Very cool. Very powerful stuff. So now I've done my part. I've done my talking. My part here is over. I want you now to step up to the plate. You need to get on your computer if you're not already there, or if you're driving or at the gym, mentally make a note to go to your computer once you are able to, and go to my website, howtoprogramwithjava.com/session4. And in that link, you will have my show notes. In the notes, you will have a link to the actual blog post where I talk about data structures, and you can go over that and look and see some examples in code of what a data structure actually looks like. And this is the crucial part, because you can't really become a programmer by just listening to someone talk about programming. It's absolutely helpful to understand the concepts such as data structures or control structures, which I talked about in the last podcast, or variables, which I talked about in the second podcast. Very useful and very powerful to know that stuff, but you need to be able to follow through and understand what the code actually looks like. And if you do go to my blog and you do go to howtoprogramwithjava/session4, you'll actually see that via the link that points to the blog post that talks about data structures, the next topic that I would talk about is something called the syntax. Okay, and I've mentioned what syntax is before, but it doesn't really translate well into audio, and I would also like you to look at the syntax post that I did to understand what the syntax is in Java, and to go through there and understand everything there is to know about syntax. Well, maybe not everything there is to know, but everything that you need to know right now. Very important that you do that. So I'm counting on you to follow through with that. I will hold you accountable for that, okay? So, that's all I'm going to say for now about this particular topic. And what I do want to do, what I do want to talk about, is something else that's going to help you out in your quest to becoming a Java programmer. I have a great resource for you to learn Java, and it's the How to Program with Java ebook. Okay? I spent a lot of time and a lot of effort to put together all of my best tutorials in an organized fashion into an ebook that you can actually download. Okay? And if you are listening to this right now, which is October of 2012, then the book is actually available for pre-order right now, and it's actually just 33% off, okay? It's my gift to you for acting early. And you can go through with this by going to javapdf.org. PDF like an Acrobat, Adobe Acrobat reader file, PDF. If you do that, that'd be fantastic. I will love you forever. All right, and if you're listening to this in the future, then just hop on over to the same website, that's javapdf.org, and you can purchase the book yourself. Now, this book comes absolutely ram-packed with everything you need to know about Java. All of my tips and tricks, all of the actual syntax, examples. It's just absolutely jam-packed with everything that you need to know about the Java programming language. And it's in plain English, okay? It allows you to go through and at your own pace, learn the stuff, and not get frustrated. I really want to focus on making sure that I don't go too fast and that I don't frustrate the reader, okay? I've been there before. I've purchased a big honkin', 500-page book. You get about 20 pages in, and it's just too complicated, okay? I've been there. I don't want you to feel the same way. This is my gift to you, okay? So check it out. Go to javapdf.org, and if you want to pre-order it, there's a 33% off. If it's no longer available for pre-order, perhaps I'll have another special offer on when you go to it. I don't know the future yet, but check it out. I'm sure you'll love it. It's great, okay? So, that's all I have for you today. I thank you for listening, and next episode, I think we're going to be talking about tools, so you can actually start to install something on your computer and get going with your actual learning and creating an actual, real, working Java program, okay? It's very exciting. So, I look forward to talking to you then, all right? So, take care, and have yourself a great day, guys. Bye for now.
Thanks for listening to the How to Program with Java podcast. Please visit howtoprogramwithjava.com for more useful Java tutorials.